All right, so like we said before, statistics, you're collecting the information, you're organizing that information, and then making interpretations about it. Okay, so like we said before with medications, does this medication work? Looking at the data, yes, this medication got rid of a headache, but it had a side effect of making me nauseous, or this wound up making my headaches last longer than it normally does. Or I took the medication, my headache went away right away, and I had no side effects. So we're interpreting what all this information means so that we can make a wise decision about that information. The method of collecting that information is through the process of taking a survey. And we're going to talk about different ways of collecting information, different surveying processes or methods, because some of them are going to be reliable and some of them not so much. Okay? What we're focusing on for today is the concept of a population and a sample. So for a population is a representation of the entire group that you're focusing on, what you're wanting information about. So for example, if I want information about after-school clubs that my students would like, students at the school, what after-school clubs do they want to see at school or after school? Am I going to ask their parents? No. You don't want to ask the parents, because I don't want to know what the parents want for you. I want to know, what do you want? Maybe you want some kind of, Minecraft after school club, and your parent thinks, no, I want them to be in chess. It's what you are wanting, okay? So the population needs to be extended to only specific people that the information is supposed to be collected about. And we also like to identify this as the big picture. Okay, it's a large group that we're focusing on. And to ascertain that information, to gather that information, we're not going to talk to every single person in the population, okay? So similarly, when they're trying to figure out, hey, who is going to be the next president, and we're trying to get an idea of who that's going to be before we actually have election day, they are constantly doing polls about who is going to be supported in the election. So those polls or those surveys aren't going to be going and asking every single person in America, but they're going to be a random selection of people all throughout. Now notice I said all throughout, because your sample needs to be a representation of your population. If I am trying to figure out who the United States is going to vote for as their next president, it would not be a wise decision for me to go and focus solely on a small town in Texas. Why would that not be a good representation of my population? I want you to think about that for a moment. If I'm trying to figure out who looks like they're going to be selected as the next president of the United States, so we've got a bunch of candidates, and we're trying to figure out who the United States is probably going to select, and we're going to take a survey. Why is taking a survey of only the people in a small town in Texas not a fair representation? Why do you think? Why do you think, May? Yeah. You're focusing on one population in one location. So I don't know how much you guys understand about politics, but a lot of times when we're looking at things, when they have political maps displayed, they're always displayed in these colors. They have dark blue, they have dark red, then they have light red and light blue. So those darker colors are saying, hey, these are states that are really strongly Republican or really strongly Democratic. Okay, so if it's dark red, then that's typically Republican state. Majority of the time, a Republican candidate is going to get voted in that state. Versus the dark blue is usually going to be Democratic. It's very rare that they ever change. Georgia used to be a dark blue, but for the past couple of years, Georgia has started to run light blue. I mean, sorry, not dark blue, dark red, but they've started to run light red because Georgia for the past couple of years has started to sway a little bit more towards a Democratic approach or Democratic candidate. So it starts to change their coloring. Okay, so those coloring maps are very different all throughout. If I'm focusing on just one little location inside Texas, which is a dark red state, then I'm going to assume that the candidate every single year is always going to be a Republican candidate that's going to win whenever we do an election. But that's not always true, okay? Because if I did the same thing in New York, which is predominantly a Democratic state, it would also not be a fair representation because, again, they tend to focus voting on just one specific type of candidate. What you have to do is get a fair spread where you do a little poll everywhere. Every state has a representation. So that way you get a good idea of who's likely to win. Now, again, these polls aren't always going to be cut and dry. Okay? In fact, years ago, everybody thought Hillary Clinton was going to win the nomination. In fact, America went to sleep and woke up completely surprised when she did not win, and instead we had Donald Trump as our president. Okay? But all the polls had suggested that she was going to win. So that's why people were in a state of shock for such a long time over that one. So samples are, these surveys, they're not cut and dry. It's not always going to be, okay, well, based off of this poll, it's always showing this. That means that's guaranteed to happen. Just like probability, nothing is ever guaranteed. Things can change. But what's important to understand is the idea that a sample has to be a representation of the population. So if I'm choosing a sample, so if I want my population to be students at school, but I'm sampling their parents, that is not representing the population, okay? You have to be representative of your population in order for it to be a fair representation or a fair sample size. And it's also important to know that they are the ones who are actually going to get surveyed. Okay, and it's not always people, it could be items as well. Maybe it might be looking at defectiveness of iPhones. Okay, so I'm going to take a survey of every 100th iPhone on a factory line to see if it comes up defective, so I can get an idea of what percentage of iPhones might be defective in this factory. Okay, so we also call this the idea of the small picture. Okay, so what we're going to do real quickly, just a couple of simple problems just to get you started on the thought process, is identifying samples and populations within these clusterings here. So if I had a survey topic of dress code changes, and I have two sets of groups, okay, the students in a middle school are set A, set B is the 7th graders in the middle school. Which one of those sets, set A or set B, would be the sample, the smaller picture? Set B. Good. The sample would be set B because it's 7th graders that are in the middle school, right? Think about it. A small picture should fit inside the big picture. So 7th graders is a part of middle school being your population. Okay. Yeah, if you've got your head down, I've already put your name onto silent lunch. Just letting you know. So please don't be surprised. Jada, head up. Jada, head up. Thank you. All right, number 2, a favorite flavor of ice cream is the survey that I'm trying to ascertain here. So the customers at an ice cream shop in this town is set A. Set B is the residents of the town. So which one of those is the small picture, the sample size? Set A, right? The customers at an ice cream shop, that's the small picture, right? That's just a portion of people that are in town going there versus everybody in town. The residents of the town, those are the people who live in the town. Not every single person who lives in the town can fit inside of the ice cream shop all at once, can they? Okay, so sample would be the customers at the ice cream shop, residents of the town is the population. These are very simple concepts of population and sample. They're not always going to be this simple though. Sometimes you're going to have to infer what the population would be based off of the sample that they're giving to you. Knowing that your sample is supposed to be a representation of the population. So here's what I mean. For scenario A, Lucio wants to know whether the food he serves in his restaurant is within a safe range of temperatures. He randomly selects 70 entrees and measures their temperatures just before he serves them to the customers. So the sample is clearly stated inside of this paragraph. The sample is what he is surveying. What is he surveying? It's not a person. What is he surveying? Huh? Temperatures, but yeah, we know he's surveying temperatures, but what specifically is he surveying here? The 70 entrees. Very good. He randomly selects 70 entrees. That would be no different than me. I'm going to randomly go up to 70 people at the mall and ask them to fill out a survey. Okay? 70 selected entrees is what is our survey population. So it's 70 entrees that are being tested. Right? We're checking their temperature to see what the temperature is, and then we're going to serve it. So the only thing that they told us was what the sample size was. Based off of the sample, we then have to infer what the population would be, which is supposed to be a bigger picture than the sample. So 70 entrees is just a small portion of what he's serving. The population is all the entrees that he serves. Every entree that he is going to serve that day is a part of the population. He's just randomly picking 70 of those entrees to test their temperature. So again, the sample was clearly stated in the paragraph. The population, I had to basically make an inference about what the population was going to be based off of the sample provided. Okay, same thing here. Scenario B. A medical research center is testing a new weight loss treatment. They advertise on a social media site that they are looking for volunteers to participate. So my sample, the only people who are going to be a part of this survey are who? The people who volunteer. Good. So those who are volunteering, they're volunteering for a weight loss treatment. That's what they are doing. So these are the volunteers. If I'm volunteering for a weight loss treatment, then what is it that I'm hoping to do?
Lose weight.
Lose weight. So they are the volunteers that want to lose weight. Volunteers that are wanting to lose weight. So now I need to make an inference based off of that to gauge what my population would be. So again, we're focusing on weight loss. So my population is everyone who wants to lose weight. So am I gearing it towards like Richie?
Yeah.
Does Richie look like he needs to lose weight?
No, he's straight.
Yeah. Mm-hmm. So you are gearing this population. I don't care for the people who are underweight or who are already fit. I'm focusing on the people who do want to lose weight or who need to lose weight. So that's what my advertisement is focusing towards. So the population is anyone who needs to lose weight, needs or wants to lose weight. Again, that information right there is not what's projected inside of our scenario. Only thing that's projected in the scenario is what the sample is going to be. And from the sample, you're going to build off of it to create your population. Okay, scenario C. A pediatrician randomly selected 10 parents of his patients. Then he surveys the parents about their opinions of different kinds of diapers. What's the sample? 10 parents who what? Who are going to survey about diapers. So, how old are your children again, Miss Horton?
Mine are 22 and 24.
22 and 24. So do you think that we should survey Miss Horton?
Yeah. Maybe.
Does she have children in diapers right now?
No.
No. I mean, you might be able to, but it's been over about 20 years since her kids have been in diapers. Diapers have changed quite a bit in 20 years. So you probably aren't going to survey Miss Horton about diapers, but you might survey somebody who has a brand new baby. Okay? My kids aren't in diapers anymore either.
Oh, for real?
My kids are 9 and 6. No, they do not. They are not in those either. But you are going to want to focus on. You got the 10 parents of patients that are in diapers. So we're focusing on people who have young children, right? Okay, so we know this. This is what's been given to us. Randomly selecting 10 parents of the patients, and we're focusing on diapers. So based off of that, what do you think is the population? Survey was 10 parents of patients that are in diapers. So 10 parents with children in diapers. What's the population going to be? Raise your hand, let me know what you think. Come on, guys. You can do this. What do you think, Hayden? All parents that have kids in diapers. Okay? Notice, guys, population, all entrees. Population, anyone or all people. You can even say all people who need to lose weight or want to lose weight. Population, all the parents who have children in diapers. Your population is everybody that has something specific here. Okay, whatever your sample is looking for, it's everybody who is a part of that kind of thing for the population. All parents with kids in diapers. Okay. Let's go ahead and turn it on over to the back. What I want you guys to do real quickly is I just want you to try problem D on your own. Just problem D. Don't go to anywhere else. Just do problem D on your own. Identify the sample, identify the population. So for scenario D, a safety inspector conducts air quality tests on a randomly selected group of 7 kindergarten classrooms at an elementary school. What do you think is the sample? Raise your hand to tell me what the sample is going to be. Actually, you know what? Don't raise your hand because I'm just going to call in random people because too many of the same people always answering. Simran, what is the sample going to be for this situation? The 7 kindergarten classes, right? So it's the 7 kindergarten classes. Okay, so now the population. What is the population going to be? Matthew. All the classrooms at the school, right? All of the classrooms. Okay, all right, the reason I didn't want you to do E is because E has been giving people trouble today. So for E, it says a quality control engineer is curious about the thickness of paint on a car in her factory. So she's focusing on just one car, just a single car. So what she's going to do is she's going to randomly select 30 points on the car and test it. So our sample is the 30 points of paint on a specific car. The 30 points of paint on a specific car. Now, everybody's been fine with that when they're like, yeah, it's the 30 points of, that she's testing, the 30 points. But then for the population, they're like, it's all cars in the factory. Is it all cars in the factory? No. It's all parts of the car. It's all parts of that specific car that's painted. Okay? All parts of that specific car. So you got to be really careful about that. So it would be different if she says she was curious about the thickness of paint on the cars in her factory, and then that she selected 30 cars in the factory to test. Then it would be all cars in the factory as the population. Okay, but she's focusing on just one car in general. All right. Scenario F, the State Department of Transportation wants to know about out-of-state license plates or out-of-state vehicles that pass over a toll bridge that has several lanes. So there's like 2, 3, 4, maybe 5 lanes, who knows? Okay, so what they're going to do is they're going to install a camera over just one of the lanes. And then they're going to take a picture of every 10th vehicle through that lane. Okay, so our sample, every 10th vehicle I misspelled vehicle in one lane, just that one lane that they're going to set up the camera for. It's every 10th vehicle in one lane. So the population, what's the population going to be? All the other cars, but not just through that lane. It's all the other cars through all the lanes, right? There are several lanes, okay? They want to be able to gauge it for everything. So it's all the cars in all the lanes. All right, last one, scenario G. A factory overseer selects 40 threaded rods at random from those produced that week at the factory. Then she tests their tensile strength. So the sample, what is she selecting? The 40 rods, right? And then what's the population? What's that keyword we always been saying? All. So all the rods that were produced that week. All the rods that were produced that week. Okay? All right, we're going to go to the last page. That last page is basically practicing what we did yesterday, which is using probability to make predictions. But what we're going to see it as is probability through survey collections, information that was collected. So it almost looks kind of like experimental probability. Let's take a look. So here we have a collection of students and where they went for summer break. So we had 6 students that took a picture at the beach, 4 students who had a picture at the campgrounds, 7 students who just had pictures from home, and 11 students who had pictures from a theme park. We want to base off of this information, we want the probability that a student brought in a photo from a theme park. Okay, so we know that probability, we like to set it up as a fraction. What information, what value or number is going to go on the top of my fraction based off of what they're saying? 11, right? We have 11 people who went to the theme park, and that's what we're focusing on. So we have 11. Okay, what value are we going to put for the denominator? Huh? The total, all of it, right? What is that total? 28. So we're now going to add all of those numbers together, and that's going to equal 28. So 28 is going to go on the bottom. So there's our probability. We have 11 theme parks out of 28 total students. Now again, like we learned, we're going to use that probability to be able to create a proportion. So we know 11 out of 28 students went to the theme park. We want to know if there's 560 students, how many of them went to the theme park. So we'll do x over 560. And then we do our cross product. What are we going to multiply together first?
11.
28 and x, right? 28 and x. We always like to do our variable first. So we have 28 times x, which is 28x, and then we'll multiply the 11 times 560. Okay, if we do 11 times 560, that's going to give us 6,160. And then we can go ahead and divide that by 28. And we'll get that x is equal to 220. Okay, now for here, we were able to set up a fraction based off of the data that was given to us. But if we take a look at problem number 3, it says a survey found that 85% of people use emoticons or emojis on their instant messengers, and then we want to figure out how many use them out of 2,450. So we don't have a set of data here, we only have a percentage. So what should I do if I need to create a fraction? I'm given 85%, how can I create that as a fraction? Say it louder, Hayden. Say 85 over 100. Remember, percentages are always out of 100. So if you want to write that down, you can circle that 85% and say that it is out of 100. It's always out of 100. So you can create a fraction from your percents by putting it over 100, and then you can still set up your proportion. We would have x over 2,450, and then we do the same idea. We do our cross product by multiplying 100 times the x to get 100x. And then we do 85 times 2,450, and that's going to give us 208,250. Then our last step, divide both sides by 100 to get x by itself. Now we'll notice though, when we do that division, we're going to get 2,082.5. Can I have 0.5 if I'm talking about people? No. So I have to round it. I'm going to have to go ahead and round that answer. So x is approximately 2,083. Make sure you understand that you need to round. We're not going to do the last one right now because I want you to be able to get started on your assignment. So go ahead and get logged in,